Welcome back, everyone. This week we're going to talk about budgeting expenses and compound interest. So if you know how much you spend on a particular expense in a given amount of time, you can determine how much you'll spend over a longer period of time. So let's say Joe spends $28 per week on pizza. What would be Joe's annual expense for pizza? So how much would he spend over the course of a year? Well, if he spends $28 per week, and there are 52 weeks in a year, 28 times 52 will give you $1,456 or $1,456 per year on pizza. In order to determine his monthly expense, we would just take his annual expense and divide by 12. 1,456 divided by 12. And the monthly expense for pizza, $121.33. So we can expand on that idea a little bit by calculating the annual budget for multiple items, and then use that to determine your monthly budget. So Jalen's car payment is $243 per month. He gets car insurance bills semi-annually, so every 6 months, for $427. He spends $60 each week for gas, and about $125 per quarter for maintenance and repairs, so every 3 months. We want to prorate each expense to determine the total amount that you'll spend over the course of a year, and then we can figure out how much you would allocate each month. So the car payment is $243 a month. There are 12 months in the year. 243 times 12, $2,916 every year. The car insurance bill is $427, and it's semi-annually, so twice in a year. So 427 times 2, $854. Gas is $60 per week times 52 weeks in a year. 60 times 52, $3,120. And then for maintenance and repairs, it's $125 every quarter. So that's 4 times a year. 125 times 4 is 500. If we add up all of his expenses for the year, his total annual expense is just the sum, 2,916 plus 854 plus 3,120 plus $500 for a total expense per year of $7,390. To find the monthly amount that he should allocate, we're just going to take that amount, 7,390, and divide by 12. And so the total monthly amount, $615.83. If we're using compound interest, then in order to determine the future value of some account, which we write as an A, we want to use this formula. Remember that P is the principal amount invested, R is the interest rate, written as a decimal, T is the term of the investment in years, and N represents the number of times the account is compounded each year. So let's practice some compound interest problems. Cindy invests $1,000 in an account that earns 4% interest compounded monthly. So monthly would mean 12 times a year, so N equals 12. Cindy wants to calculate how much money will be in the account in 5 years. Identify the value used for each variable in the compound interest formula, and then determine how much money she will have in 5 years. So the principal, the amount that's being invested, is $1,000. The interest rate is 4%, but remember to write it as a decimal, so 0.04. The amount of time is going to be 5 years. And N, because it's compounded monthly, like we said before, is equal to 12. So to calculate the future value, A equals P times 1 plus R over N raised to the power of N times T. That's 1,000 times 1 plus 0.04 divided by 12 raised to the power of 12 times 5. 1,000, 1 plus 0.00333 12 times 5 is 60. This equals 1,000, 1.00333 to the 60th power, or 1,000 times 1.22075, $1,220.75 at the end of 5 years. Julianne has $500 to invest in an account that earns 2.75% interest compounded quarterly for 5 years. We're going to identify all of these variables again, and then we're going to determine how much money she has in 5 years, and then we're going to compare this to a different account. So the principal, the amount she's investing, is $500. The interest rate is 2.75%, but we want to write this as a decimal, so 0.0275. The term again is 5 years, and n, because this is compounded quarterly, n is equal to 4. It's compounded 4 times a year. To find the future value, a, we're going to use our compound interest formula, 1 plus r over n, to the n times t. So that's 500, 1 plus 0.0275 divided by 4, to the power of 4 times 5. 0.0275 divided by 4 plus 1. This is 500 times 1.006875 raised to the 20th power, which is 500 times 1.14686, or $573.43. If she has another option at a 2.65% interest rate, but it's compounded monthly, which one will give her a better return? When will she make more money? Well, again, we're going to invest $500. The interest rate now, though, is 0.0265. The term is still 5 years, but it's compounded monthly, so n equals 12. Then to find the future value, that's 500, 1 plus 0.0265 divided by 12 now, raised to the power of 12 times 5. That's 500 times 1.0022083 raised to the 60th power, 12 times 5, which is 500 times 1.1415122, or $570.76. So after 5 years, she'll have more money in the first account, $573, as opposed to the second account. Please let me know if you have any questions.